Now let's practice our discrete probability skills with a complex multi-step probability problem. In this case, we have a drawer, we have a top drawer and a bottom drawer, and different ratios of colored socks in each drawer. So in the top drawer, we have 3 out of 4 socks being black, and in the bottom drawer, we have 1 out of 5 socks being black. So we can just assume that in the top drawer, there's 4 socks in total, and there's 3 of them that are black. In the bottom drawer, there's 5 socks in total, and 1 of them is black. Now, let's say we're in the dark and we're trying to choose a sock and match a pair, right? So we have a half probability of randomly choosing the top or the bottom drawer because, the question says there's 50-50 probability, but it just makes sense, right? If you're in the dark, you can't really see what you're doing, so you just choose one randomly. So we can just say the probability of choosing the top drawer randomly is 1/2. Now, the next question asks for the probability that a black sock is from the top drawer, or the probability of choosing a black sock from the top drawer. So we can think of this as like a multi-step event, and we use our intersection because we want the probability of choosing the top drawer and then a black sock from that top drawer. So what you do is, okay, what's the probability of choosing the top drawer? It's just 1/2. Now that we've chosen the top drawer of 1/2, there's a 3/4 probability of choosing a black sock. So what we do is we do 1/2 multiplied by 3/4. Now, if you want to do the full working out for this question or show even more working out, to be honest, it's unnecessary. But if you want to understand where this comes from, it's because choosing this and, these individual probabilities are independent events. So what we'll do is we say black sock, the probability of black sock intersected with top drawer, okay? But obviously you just have to take into account that this black sock probability changes depending on which drawer you choose. So it's 1/2 multiplied by 3/4, which just becomes 3/8. I'll just write that a bit bigger. Cool. Now, what's the probability of choosing a black sock in general? So this is a bit more broad because it's not focusing on the top drawer. It's kind of implying that you can choose a black sock from either the top or the bottom drawer. Now what we should do is think about the different combinations of choosing black socks. So we can either choose a black sock from the top drawer or a black sock from the bottom drawer. Now, a lot of people would draw a tree diagram for this event, which is more than okay in this case. So we can have the top drawer or we can have the bottom drawer, and we can have black or not black, BL for not black, BL dash for not black, sorry. So BL and then BL dashed, okay? So the probability of choosing a top or bottom is 1/2. Probability of black sock there is 3/4, therefore this one is 1/4, this one is 1/5, therefore this one is 4/5. Now, if you want the probability of choosing a black sock, it's either going to be down this path or this path, because that's top drawer, black sock, bottom drawer, black sock. So therefore, if we just multiply the probabilities in each branch and add them together, we get 1/2 multiplied by 3/4, which is actually what we did before. I'll just write the full calculation out. And then plus 1/2 multiplied by 1/5. So we get 3/8 added with 1/10. These numbers aren't the best. What's the common denominator of 10 and 8? It's 40. So this becomes, so that was a bit of a thinker. That took me a little while than expected. So this will become 40 by multiplying by 5. Therefore, this one is 15. This one becomes 4. This one becomes 40. Therefore, we get 19/40. And that can't be simplified any further. Sweet. Now the last question, which is the hardest part, what's the probability of the sock coming from the top drawer considering it is a black sock? So we can go ahead and use the formula, and then we'll do the conceptual way, kind of backwards to the previous video if you watched it when I introduced conditional probability. So what we can do is we'll say the probability of a sock being from the top drawer and black divided by the probability that it's a black sock in the first place. So the probability of a sock being from the top drawer and a black sock is what we calculated before, which is 3/8. And then we divide it by the probability of it being a black sock in general, which is 19/40. So what we can do is go ahead and simplify this fraction using state change flip. So go 3/8 multiplied with 40/19. Now, a lot of the times when you get to this scenario, a lot of people just multiply across, but don't do that because the numbers get really large. Look for common factors that you can actually cancel out. So this cancels out to 1, this cancels out to 5, and this actually ends up being pretty easy. Ends up being 15/19. Now, Whenever we get answers in probability, it's good to kind of think about if they actually make sense or not, because probability should always reflect real world statistics, let's say, if the numbers are realistic. And in this case, what we can do is think about if 15 on 19 actually makes sense as an answer. Now, how do we actually figure out if it makes sense or not? What we do is we think about what this conditional probability is actually saying. So again, we're going to kind of interpret what the conditional probability means. What's the probability that a sock comes from the top drawer, given that we already know that it's a black sock? So in this case, where can you see a more likely black sock being chosen from? Is it going to be from the top drawer or the bottom drawer? You can clearly see that it's going to be from the top drawer because it just has a much higher ratio and a much higher probability of a sock being black from that drawer. So therefore, if a sock is black, it is very likely to be from the top drawer. That just makes sense, conceptually. So therefore, we actually expect a high probability here, and which is what we get. We get 15 on 19, which is roughly 75% or so. Not quite, but it's around 75%. You can see it's much higher than 50%, which was the original probability of choosing a top drawer. So given that the sock is black, that actually increases the probability of us knowing that the sock's from the top drawer, which, yeah, again, it makes sense conceptually. So it's good in general, not specifically for this question, but just in general to think about if your answers make sense from a probability and a statistics standpoint, because if they do, then your answer is most likely right, and you can kind of ensure, and you kind of be assured of the fact that you actually did the question correctly.